Section 6.3 Trigonometric equations involving multiple angles. So it's not going to be just sine alpha or cosine alpha. It could be like sine 3 alpha or cosine 3 alpha, so that the angle is being multiplied by a constant. To do that, or to solve this kind of questions, let's look at an example or examples on this. These examples will be solved, and if we can first make them easier by recalling this stuff that we learned before. So if sine alpha equals sine beta, then to solve this kind of equations, alpha equals beta plus 2k pi, where k is an integer, or pi minus beta plus 2k pi. K is an integer. That was for sine. If we applied for cosine alpha equals cosine beta, then we have alpha equals beta plus 2k pi, or alpha equals negative beta plus 2k pi. K again is an integer. And for tangent, if tan alpha equals tan beta, then we have one equation here, alpha equals beta plus k pi, k integer. Those are really important tools. Or you can just get the solutions using the unit circle. Either one is fine. So let's look at how do we solve equations such as sine 2 alpha or 3 alpha, whatever you like, equals square root of 3 over 2. Alpha is given from 0 to less than 360 degrees. So let's see what we get. How do we solve this? Based on my strategies, we look at the one on the left side. Is there an angle its sine is rad 3 over 2? Yes, there is. It's 60 degrees. That's the smallest angle. So now I apply the properties or the formula I just wrote up there, that this equals 60 plus 360k, or this equals 180 minus that number plus 360k. This can be replaced with 120 degrees. So k is an integer, always state so. Now we are going to divide the top by 2. So alpha equals 30 plus 180k, and alpha equals 60 plus 180k. Do you see the difference between this section and the previous section? In the previous section, we always got alpha equals something, alpha equals something. Here we got 2 alpha, or maybe you can see 4 alpha or 3 alpha. You must divide by that number first. So now let's see what we get. We can take k values. K equals 0. Alpha would be 30 degrees and 60 degrees from the first and second equations. If I take k equals 1, then alpha would be 30 plus 180. That's 210. 60 plus 180, 240 degrees. I got 4 values so far. If I take k equals 2, each one of them will exceed 360. So we don't have to worry about that. So now, do I have to check them out? Well, let's see. Did I square both sides? Or no, I didn't. So we don't have to check. So these would be the alpha values. So what's the difference between this and the previous stuff that we did in the previous sections? One of the things that is different here is that when we had it before, it was only alpha equals something, and then for such equation like this, we only got 2 values, but here we get 4 values. So just so you know, usually as we increase that number to alpha, like 3 alpha, you will get more solutions. 4 alpha, you get more solutions. 5, you get more, because that makes this stuff here even smaller and smaller. So when we do the division, so we end up having more and more values that fall between 0 and 360. 0 and 360 degrees. So that's why. What about another one? Find all radian solutions. All radian solutions for tan 3x equals negative 1. So how do we do that? Well, what's the smallest angle is tangent is negative 1. Not 45. 45 would be for 1 only. that would be tangent 135 degrees, 135, which is 3 pi over 4 radians, because it says radian measures. So now we have one formula for tangents, is either alpha equals beta plus k pi. That's all we have, k integer. And do we leave it like this? No, it would be really best we divide by 3. So, or multiply everything by 1/3. Like you multiply here by 1/3, here by 1/3, and here by 1/3. So then that gives me the 3 cancel, pi over 4 plus k pi over 3. And that's where you stop. You don't have to take values for k. And why is that? Because they are asking for all the radian measures, So we don't have to move further with this. So this will generate all the radian solutions for us. If you take k equals you get 1, k equals 1, you get another one, k equals -1, you get another one, and so on and so forth. So there will be infinitely many of them. How about if we are asked to solve something like this? Cosine 2x, cosine x, minus sine 2x, sine x, equals 1/2. What do we get here? What can I do with this? Well, I see double angle formulas in here. You can probably use double angle formulas, but that will take a lot of work. This reminds me, this looks like cosine minus sine. So cosine alpha cosine beta minus sine alpha sine beta. Oh, we had a formula for that. But before that, let's restrict the values of x from 0 to 2 pi. This looks like that can be written as cosine 2x plus x, and keep the 1/2 the same. So go back to the formula that says cosine alpha plus beta. It's cosine minus sine. So if you go backwards, you will see that you got that. So on the left side, we get cosine 3x is 1/2. And what is the smallest angle? Its cosine is 1/2. That's 60 degrees, or pi over 3 radians. Now I got an equation here that looks like cosine alpha equals cosine beta. We can use the formula I gave you before, that this equals that plus 2k pi, or this equals negative pi over 3 plus 2k pi. Always good to state that k is an integer. So now we can take the first equation and divide everything by 3. That will make it 9, and that's a 2k pi over 3. If you divide here by 3, that will make it a negative pi over 9 plus 2k pi over 3. And now it's ready for us to select values for k. So we're going to take k equals 0 and see what we get. So if k is 0, x would be pi over 9 from the first equation, and negative pi over 9, which we don't need. If k equals 1, let's see what we get. We get pi over 9 plus 2k pi over 3. So to combine them, you multiply by 3 top and bottom, because that's a common denominator. That gives us pi plus 6, so we replace the k, 6 pi over 9. That gives 7 pi over 9. That's still within 0 to 2 pi, that's okay. If I substitute in the second equation, negative pi over 9 plus 2 pi over 3. So multiply top and bottom by 3, common denominator 9, so 9, negative pi plus 6 pi, so that gives us 5 pi over 9. So far I have pi over 9, 7 pi over 9, 5 pi over 9. That's when k is 1. What about if I take k equals 2? What do we get? Let's see. X equals pi over 9 plus, substitute the 2 in, 4 pi over 9. So 4 pi over 3. So multiply top and bottom by 3 again. What do we get on the top? We get 12 copies and 1. That's 13 pi over 9. That's still within 0 to 2 pi. If I substitute in the second equation, negative pi over 9 plus, put the 2 in, that's 4 pi over 3. Multiply by 3 and by 3. That gives us 12 pi minus pi, 11 pi over 9. So k equals 3. Let's see what we get. x equals pi over 9 plus, replace k with 3. 3 times 2, that's 6 pi over 3. So 6 pi over 3. You can write as 2 pi if you like, but you can leave it as, because I'm going to multiply either way. That gives us 18 plus 1, 19 pi over 9. That's still within, wait, that's more than 2 pi. That's more than 2 pi. So we don't need this. We don't need this value. It exceeds 2 pi. Another thing to pay attention to here, you could have seen it here, even without multiplying. This is really pi over 9 plus 2 pi. So 2 pi plus anything is exceeding 2 pi. So that's for the first one, but doesn't mean it's not going to work on the next one, which is negative pi over 9 plus 6 pi over 3. If you multiply this by 3, that gives us 18 minus 1, 17 pi over 9. So that gives me the next value. If I take k equals 4, that will exceed 2 pi for both of them. So the answers that I got is 1, 2, 3, 4, 5, 6 answers. So do you see why we got more and more answers here? Because the number in the front was not 1, was not 2, was 3. Do you see the 3x? That's why we got more answers. So the more you increase that number, the more answers we generally get. Next one. So what about if we're asked to solve? Let's say we are asked to solve sine alpha minus cosine alpha equals 1 and alpha between 0 and 2 pi. So you might say, wait, this looks like a problem we did in the previous section. Yes, the previous section, instead of 1, I put 0, something similar, but I put 0. And it was easier to kind of like solve by squaring both sides. But here, there's several ways to do this. You can first add cosine alpha to both sides and square both sides. Or you can subtract sine alpha on both sides and square both sides. All of this will work. Or you can go ahead and square both sides right away. So keep this the same, minus cosine alpha, square this equals 1 square. And then what we get for this one? You square the first one, minus 2 sine alpha cosine alpha, plus cosine square alpha. So I'm using a minus b square formula, which doesn't say you square the first minus square the second. Make sure there's a minus 2 sine cosine. So sine square alpha plus cosine square alpha, that's a 1. Minus the 2 sine cosine, that's the formula for sine 2 alpha, the double angle formula. What do we do next? We can subtract 1 on both sides. That will make it 0. Multiply by negative. We don't like to see negative sign in the front. That would be 0 again. And then this stays the same. This is sine of 0, because sine 0 is 0. That's the smallest angle that its sine is 0. Now I can use the formula that we gave before. So 2 alpha equals 0 plus 2k pi. Wait, is it radians or degrees? Radians. Or that angle is pi minus 0 plus 2k pi. K integer. So it's not ready because I need to divide by 2 both of them. Alpha is k pi, or alpha is pi over 2 plus k pi. Now because there's a restriction on alpha, we must select values for k. So when k is 0, we get alpha is 0 on the first one and pi over 2 in the second one. When k is 1, what do we get? We get alpha equals pi, and in the second one we get pi over 2 plus pi, which is 3 pi over 2. So far we have 4 values. If I take k equals 2, that would give me 2 pi for the first one, which we don't need, and 2 pi plus something for the second one, which exceeds 2 pi. So we have 4 values. Always after you solve a trigonometric equation, ask yourself, should I check the answers? Yes, we must check it here because we squared both sides. So let me write the original equation down here. So we need to check the obtained solutions. We had sine alpha minus cosine alpha equals to 1. Let's take the first value, alpha equals 0. What we get? We get sine 0 minus cosine 0. Is that going to be 1? Well, this is 0 minus cosine 0 is 1. So that's a negative 1. It doesn't work out. Doesn't mean we did something wrong. This is just extraneous solution. We don't need. So alpha equals pi over 2. Let's see if this works. So sine pi over 2 minus cosine pi over 2. Is that going to give us 1? Let's see. Sine pi over 2 is 1 minus 0. Yes, it does check. So this is okay. This is an answer. The next value we obtained was alpha equals pi. Let's substitute that in. So we get sine pi minus cosine pi. Let's see if that's going to give us 1. This is 0 minus 1. That's a negative 1. This doesn't work. Doesn't check. The last one was 3 pi over 2. Sine 3 pi over 2 minus cosine 3 pi over 2. Actually, wait. Cosine pi was negative 1. So that was a minus minus. So that's a plus. This one checks as well. So it's important to see that there are double negatives. So easy to miss. For this one, sine 3 pi over 2, which is 270, its sine is negative 1 and cosine is 0. So that gives us negative 1. That doesn't work. So there are only two values of alpha that works out. Pi over 2 and the pi. These are the only values. So these are the only solutions to that given equation. Now, what about if we have more complicated kind of equation to solve? So let's say we're asked to solve 2 sine square 2x, so it's quadratic and double at the same time, minus 6 sine 2x plus 3 equals to 0. Let's say we are going to restrict the solutions if x from 0 to 360 degrees. So how do we handle this? How do we solve such equation? Well, the first thing to me, I looks like, wait, sine 2x, they look the same. Like if you really on the side happen that you want to take sine 2x to be m, that equation turns to be 2m squared minus 6m plus 3 equal to 0. If you like to solve it this way, we can do so. So you can say let sine 2x equals m. The given equation becomes 2m squared minus 6m plus 3 equals to 0. So what do we do in this case? How do I solve this? We're going to try to factor it out. So if you try to factor this one out, you get 2m and m. Maybe minus 3 minus 1. Test it out. Minus m minus 6. Oh, that doesn't work out. What if I put the 3 here and the 1 there? Minus 3 minus 2 minus 5. Oh, that doesn't work out. So no matter how we try it, we call this method is called trial and error. You try and you make an error, you try it again and it's not working. So the only thing we have to use is the quadratic formula. I'm going to write the formula here. If you have ax squared plus bx plus c, just to recall it. The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac over 2a. That's the quadratic formula. So if you stuck on this by factoring it, you can always use the quadratic formula. So for here, m, which is sine, so m sine 2x, is negative b, so it's 6 plus or minus the square root of b squared minus 4 times a times c divided by 2a. So sine 2x equals 6 plus or minus, if we simplify the quantity under the radical, that's 36 minus 24. 4 times 3, that's a 16. So we got 36 minus 24, which is 12 over 4. We try to simplify if possible. Like the 12, I can simplify it by rewriting as 4 times 3. Then we can take the 4 outside as a 2 and keep the 3 inside. And I can't simplify 4 with 2. Don't reduce it that way, or 6 with 4. So the only way to reduce this is to factor a 2 out first, and 3 plus or minus the square root of 3 over 4. By 2, 1, by 2, 2. That gives me sine 2x equals 3 plus or minus the square root of 3 over 2. Now, we don't know an angle it's sine like this, but 2 sections prior to this one, we went over some examples how to deal with this kind of problems. If the right hand side it's not something that we are familiar with. So the plus or minus, the first thing I'm going to do, I'm going to split this into two things. One is 3 minus the square root of 3 over 2, and the other one is sine 2x is 3 plus the square root of 3 over 2. This one, if you put on the calculator, I got about 2.37, which exceeds 1, right? Exceeds 1. So this has no solution on that side. So let's focus on this one. Put this in the calculator. Let's see what we get. 3 minus square root of 3 over 2. That gives about 0.63. Then 2x would equal to sine inverse of 0.63, which is about 39.05 degrees. Okay, we got to that point. Now we have two solutions. If you remember, 2x equals that angle that I just got plus 360k. The other one is 2x equals 180 minus that angle here plus 360k. So then if I divide everything by 2 here, if we do that on the calculator, let's see what we get. That's a 19.525 plus 180k. And for the other one, if you do the calculations, this is 140.95 degrees. Divide by 2, that gives 70.475 plus 180k. So I got to the point where now it's ready for us to select values for k. So when k is 0, x is 19.525 degrees, and for the other one 70.475 degrees. Then if k is 1, x would be 180 plus the 19 point something, that's 199.525 degrees. And the other one is 70, I don't have to put x equals, 70 plus 180, so that's 250.475 degrees. So I got 4 values. Do I have to check them out? Let's see. We don't have to, because we didn't square any or raise both sides to square power or any even power. The other thing, if in case you did the work on the calculator, you got this, and you look in the back of the book and say, wait, the answers look slightly different, like the back of the book got 19.6 instead of 19.525, or the back of the book got 200 degrees instead of 199.525 or 199.6. That's fine, like it's not like perfectly, because we're rounding up and down here to get an estimated values for x. So that's how we solve quadratics. So one thing to keep in mind while you're working with this chapter, every time you come across an identity or a formula or a restriction or a trick, strategy, you come across, write it on a separate piece of paper. By the time this entire chapter is over, then you will find out that that you summarize all the tricks that you need to know to be able to solve almost all the trig equations in this chapter. And every time while you're working on the homework problems, if you come across a question that you might think, oh, it's so difficult, what am I going to do, where should I start, come back to these notes or the videos, and those will help a lot to get a kind of give you a head start on the problem. Where should I start? Oh, I should be doing this first, or this one first, or this one before, or this step. It helps a lot. It helps a lot. So that's what this section is mostly about, is working with equations or trigonometric equations with as you know from the type involving multiple angles. Multiple means it's not just alpha, but maybe 2 alpha, 3 alpha, 4 alpha, and so on and so forth.